Okay. You know, this n, we can see the different values. Let's see some different values for n. If we have a n is 50, then what do we get? That will be first 50 tens. Okay, then you have S50 is 256, and then 1 minus 3/4 to the 50 to the 50. Okay, then you have a 256, and here is 1 minus 3/4 to the 50. What is that number? So you have a parenthesis 3/4 to the 50. Hit enter. You have a 5.663 until 64 e to the negative 7. E means exponent, so 10 to the negative 7 is, we have 7 zeros. 7 zeros, including the 0 before the decimal point. And then we have a 5, 6, 6, 3, 2, 1, 6, 5, 6, 4. 5, 6, 6, 3, 2, 1, 6, 5, 6, 4. Okay, you can store this number into variable x. Okay, now 1 minus this number, apparently this number is very small, so you can use 1 minus, get this number out. You want to recall this number from x, so you see this 1 minus this number is quite close to 1. Okay, and then if you times 2 times 256, this number is quite close to, let's say approximately, it's 255.999855. Okay, now this was n equals 50. You may try another one. If n equals 100, so then we have S100. Instead of first 50 times, we have 100 times. All the numbers are positive, so you can imagine this number must be big. Okay, bigger than this one. This one only 50 times. This one is 100 times. Okay, let's see how the number would be. To the 100th. So that's 256 here. 1 minus 3/4 to the 100th. Let me put 3/4 to the 100th. You see here is exponent to the negative 13th, even smaller than this number. Okay, so then we have a 13 zeros, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 5, 12, 13. Let's see. 13 zeros, and then 3, 2, 0, 7, 2, 3, 2, 0, 7, 2, 0, 2, 1, 9. Okay, you can store again this number into variable y. Alright, now then 1 minus this even smaller number, apparently then this number is even closer to 256. Okay, you see 1 minus, you recall this number, oh, it's 1, you see. Okay, so this number is approximately 1 times 256, is approximately 256. Okay, so in 110th, this number, the sum, is close to 110th, is close to 256. If you add more, then it's even closer to 256. Okay, so then the reason is what? The reason right here is that n goes to infinity, this 3 over 4 to the n is getting smaller and smaller. You see, from here to here, this number is smaller than that one. Okay, so it's getting close to 0. You see, we got more zeros. And then what? And then 1 minus 3/4 to the n is close to 1. Okay, because 1 minus a very small number is closer to 1. So then what we have is 256 times 1 minus 3/4 to the n is close to 256. Well, this is n gets from 50 to 100, this is a infinite geometric series. So the number can increase infinitely. And then, the conclusion is that Sn, because upstairs is Sn. This is upstairs is Sn is going to approach 256. N goes to infinity means we add all the tens together. Okay, so in this case, we may not use n anymore because n is only finite tens. Then we say S, the sum for 64 plus 48 plus 36 plus 27 plus equals what? Equals is just, you see, this one goes to 0. This one 3 over 4 to n, this one goes to 0. If this one goes to 0, 1 minus 3/4 to the n goes to 1. Okay, it's actually here it says that this part approaches to 1. That's what he says. Okay? Or you may say this part approaches to 1. Okay? So that's what. Then that's we know this is 256 from here. But you know, if you consider the formula, that's 64 times 1, because upstairs goes to 1. Divided by 1 minus 3/4. Actually, we are done up to here. This is a general formula. What's the general formula we get from here? The general formula from here, you can see that would be A1, because 64 is the first term, times 1 over 1 minus R. Okay? And that's S. That's our S. So in this case, you know, is that there is a critical point down here. If this number is less than 1. Is less than 1, so to the n goes to 0. If here is a ratio r is greater than 1, then n to the, for example, 2, then you know 2 to the n is a very big number. And you will never get 1 minus a big number is going to be 1. It's impossible in that case. So here, this ratio has to be less than 1. You know, 1 times the previous 10 make the number, following number smaller. And another number times the 48, you get 36. So number is getting smaller and smaller. Then it's possible. So we call in this case is actually this series you will see in calculus is this series converges. Okay, so the sum exists. Okay, converges. Okay. Yeah. There are cases if r is greater than, again, is greater than 1, we won't get that. Okay, here we get another formula. Next time, probably I want to use it. Okay. I'll stop right here.